When we look out into the vast dark emptiness between stars and galaxies, it's easy to assume it's a place of absolute cold. A perfect zero. But modern cosmology tells us something far stranger. Deep in the void, where there's almost nothing at all, there's a persistent, uniform glow that gives empty space a measurable temperature. Why? Because the void isn't really empty at all. It's filled with the cosmic afterglow of the universe's birth. The story begins about 380,000 years after the Big Bang. Before this time, the universe was a scorching hot soup of charged particles, a plasma that was completely opaque to light. Photons couldn't travel freely, they were constantly scattered by electrons. But as the universe expanded, it cooled. The temperature dropped just enough for electrons to combine with protons, forming the first stable atoms. This monumental event, known as recombination, had a profound effect. The universe instantly became transparent. The photons that were once trapped were finally free to travel through space. This burst of light, set free at the moment of the universe's clarity, has been traveling ever since. As these ancient photons traveled through the expanding universe, a remarkable thing happened. Their wavelengths were stretched. This phenomenon is called cosmological red shift. The expansion of space itself lengthens the light waves, decreasing their energy and consequently cooling the radiation. What began as a flash of intense, visible light, equivalent to the surface of a star, has been stretched over 13.8 billion years into a faint, cool glow of microwaves. This faint uniform glow is what we call the cosmic microwave background, or CMB. It's a fossil relic of the Big Bang, a cosmic fingerprint of the universe's infancy. And this is what gives empty space its temperature. When we measure this background radiation, we find it has a remarkably uniform temperature of about 2.725 Kelvin, which is just 2.725 degrees above absolute zero. This is the thermal bath of the cosmos. Any object placed in deep space, far from a star, will eventually cool down to this temperature, reaching equilibrium with the CMB. So, while a true theoretical vacuum has no temperature, the space around us is permeated by this ancient light. It's a powerful reminder that our universe is a dynamic, living system, and even in its deepest, darkest corners, there's still a faint, warm echo of its beginning.